Let's do some examples related to differentials. We'll start with straight up find the differential question. And to find the differential, what that really means is to find dy. So if we're going to find dy, we need to take the derivative. So dy by dx equals negative sine pi over x times x, and there's the chain rule, so we've got to multiply by the derivative of the inside, which is pi. And that tells us that the differential is, I'm going to treat these as separate independent variables and move the dx, multiply both sides by dx. So my differential is negative pi sine pi x dx. So for small changes in dx, I can calculate how small a change my y value will have. So let's add a little bit of extra information into the next example. Here I'm giving a function and I want to find the differential at a specific point. So again, if I want the differential, I need to find the derivative, which is e to the x over 4 times the derivative of the inside, which is a quarter. I'm going to treat these separately, so I'm going to move the dx over. I said I was going to do it and then I don't, so let me erase that again. So dy equals 1/4 e to the x over 4 dx. And at this point I'm going to plug in my values of 0 and 0.1 to figure out my dy. And if I do that, I get e to the 0 times 0.1, which works out to be 0.025. So what does that mean? That means that if I have a exponential function and I'm looking at x equals 0, then I move over just a little tiny bit to 0.1, then my y value is going to change by approximately 0.025. It's going to go up by 0.025. Is it an exact value? No, because we're using the slope of the tangent line to estimate that dy, not the actual function. Moving on to a third example that sort of puts those two pieces together. We've got a square root function. And I am going to look at what happens at x equals 1, where I know that y equals 1. And then I'm saying, hey, what happens to that if I change my x value by 1? So let's say I go over to 2. Change dx equals 1, moving over 1 unit. How big is my dx, dy, and delta y? So really what that means is that I've changed my x value, so dx equals 1, and we assign dx and delta x to be the same, and that means my y value is going to be different. So delta y is going to be different. I could calculate what my delta y is by just plugging in my new x variable into here. So let's start with that and say y at this point here is square root of 2. So there we go. We've got this as the square root of 2. Now, what would my delta y then be? My delta y would be this distance right here, which would be root 2 minus 1, because this has a y value of 1, and this has a y value of root 2, so the difference between the two is root 2 minus 1. So there's no calculus involved, but I would need a calculator to calculate what this is. If I want to figure out what dy is the differential, so dy over dx, I'm going to take the derivative, which is 1/2 x to the negative 1/2, separate the differentials out, or sort of isolate them one on each side, and then input my information here into my differential equation. So I get 1/2 the square root of 1 times dx, which is also 1. So that equals 1/2, which is 0.5. So if I used my tangent line approximation, my dy is a little bit bigger, it would be 0.5. How far off is it? Well, this is equal to So I'm just going to use my calculator here. Square root of 2 minus 1 is 0.4. Oh, I put the bracket in the wrong spot there. 0.41. So my delta y is 0.41 and my dy is 0.5. And you might argue that that is a big difference, but we've also made a relatively large jump here. So that's how all these variables are put together. Let's do one last example where we're going to talk about a specific example. So if let's say we were measuring the height of a building. I'm sure you did this in grade 9, or height of a tree, and you were exactly 30 meters away. Say we could measure that pretty accurately, and you're going to use an inclinometer to measure the height of the building. So you're going to use something that'll measure this angle, and then you're going to estimate this height. So the relationship between these three variables is the tan function, which is the tan of theta equals h over 30, which means the height is 30 times the tan of theta. How accurately, my question now is, how accurately do I have to measure this angle so that I have less than a 4% error in my height calculation? So if I want less than 4% error, that means that the first thing I'm going to think about is that I'm going to dH, I'm going to use a differential, so I want to calculate the differential dH. That means I need to take the derivative, so dh by d theta is 30 secant squared theta, which means dH is equal to 30 secant squared theta d theta. So I'm going to have a little change in h if I have a little change in d theta, and I want to know how small does this have to be so that this only represents 4% of the total. So remember in an earlier video, 4% relative error was given as this little difference divided by the total. So dH compared to over h times 100. So that's the percentage relative error. And I want this to be less than 4%. So I have dH, which is 30 secant squared theta d theta. I have my h value, which in this case is 30 tan theta, and that has to be times 100, has to be less than 4. So for my specific case, let's say I measure this to be approximately 75%, 75 degrees. So if that's approximately 75 degrees, how accurate do I have to measure that? So that would be 30 secant squared of 75 degrees over 30 tan 75 times 100. Oh, d theta, forgot that. And that you want that to be less than 4. So now isolating the d theta, and I'm going to multiply both sides by 30 tan 75. So 4 times 30 tan 75. So I get 30 secant squared 75 d theta equals 447.8. Divide both sides by 30 and divide by the secant squared, which is the same as let me put a new page in here. So I have 30 secant squared of 75 d theta equals 447.8. So d theta is 447.8 divided by 30 secant squared 75. And secant, remember secant theta is 1 over cos theta. So that means that this is the same as 478.8 cosine squared 75 over 30. So picking up my calculator again, times, and make sure when you use your calculator that you're going to use it in degrees. Put it in degrees mode. And then, so I get theta, d theta has to equal 0.9999, so that you have to measure to within approximately a degree, if you round that up, 1 degree if the original angle is 75 degrees, so that your error in your height is less than 4%.